Okay, now uh, for polygon, if you have shape like this, that's not a polygon. It's not closed. So when we say doing here, it's not a polygon, but we can connect them. So now they are closed, and all the lines kind of has connected. So this is what we call a polygon, and depends on how many angles we have different names. So, for example, if we got three sides, we call that triangle, which is we got three angles. And sometimes people call this a three-gon, because remember, gon just means angles. So three angles, which is basically triangle, what that means. Then we have something called quadrilateral. Quadrilateral means you got four sides. So a square is a quadrilateral, and you could have something like that. That could be a triangle. You could have kind of weird shape. Uh, say, for example, you could have something like this that have four sides. And that's also a quadrilateral. No, normally we don't think quadrilateral like this, but by definition, this is a quadrilateral. And so then when we get into more than four, we follow the same form is a number. Of course, that's in the Latin word, and the angle. For example, this one we got five angles, which have five sides. This is called the pentagon. And when we have six sides, that's called hexagon. Hexagon. And if you got seven sides, that's called heptagon. So 1, 2, 3, 4, 5, 6, 7. Kind of weird one, but still have seven sides. That's called heptagon. And then, of course, we got octagon when we have eight sides. 1, 2, 3, 4, 5, 6, 7, 8. So we got octagon. We also can have nine sides. Nine sides called nonagon. And we also could have something called have 10 sides or 10 angles. That's called the decagon. Yeah, when we say this part, deco, that's what means 10. Remember, we have decimal. That's where it comes from. So decagon. Okay, so that's basically the polygons. And last week we talked about triangles. We talked about the seven types of triangles. So let's do a review here. Seven types of triangles. Okay, so we got we got equilateral. All seven sides are the same. Equilateral triangle. And we also have isosceles. Then we got three kinds of isosceles. We could have isosceles, and all the angles are acute, so it's called acute isosceles triangle. Then we got this and this a congruent. This is called right isosceles because this is a right angle here. Right isosceles. Nope. And then we have acute, no, obtuse. So the angle here, this is more than 90. So obtuse isosceles. So now we got 4 kinds. And then we also got 3 kinds dealing with scaling. They'll have different side. The size lengths, the side lengths are different. So this is acute scaling. Then we have right scaling. We got that. Right scaling. And then we have, of course, we've got obtuse scaling. Okay, are we good on that? All right. Grayson, good? Okay. So now today we're going to focus on quadrilateral. Okay, quadrilateral have 4 sides. Then we have different kind. The simplest one will be this. You got 4 sides. They are all congruent, and also all the angles are not 90 degrees. That's called right angles. Right angles. So this is called square. I mean, this is pretty much we're familiar with. But you could have something which is, even though all 4 sides are the same, but the angle is not 90 degrees. So this is called a rhombus. And of course, you could have something like this, which this is 90, this is 90, this is 90, this is 90, and this called, but this side and this side congruent, and this side and this side congruent, but this side is not congruent to that side, so that's called rectangle. Basically, rec means right, so right angle, and we could have something like this. And we got this side and that side are parallel, and this side and this side are parallel. So we use this kind of symbol to indicate they're parallel. And this is called parallelogram. Parallelogram. And we could have something called like this. This side or this side congruent, and this side and this side are congruent. This actually is called a kite. Kind of like you got kite, just a kite you fly. And you actually have 2 isosceles triangles put together. Then lastly, we got something like this. And this side and that side are congruent. And this is called trapezoid. Now, of course, you could have something weird, but something like this, and we just call them quadrilaterals. And so you can see that the special kind of quadrilaterals, we got uh, um, a square, rhombus, rectangle, parallelogram, kite, and trapezoid. Okay, are we good on this one? Very good, very good. Then we can, in a way, we can regroup them from general to specific. A general quadrilateral could be just something like this. So we saw the quadrilateral. Now, if we got something like, say, all 4 sides are parallel, oh, actually just 2 sides are parallel, then we got trapezoid. Now, a special case, you can think, we can connect it. The special case for the traploid will be a parallelogram. This side parallel, this side, this parallel. That's called parallelogram. And a special case parallelogram would be this. That's a rectangle. So basically, a rectangle is a parallelogram. Okay, so this is a special case of that. So we got this. And of course, a special case of the rectangle is a square. So square, we got all sides are congruent. And we can see that we could have a special case of this, which is rhombus, and that could be something. So we know this side and this side parallel, and this side and this side parallel. So it's a special case parallelogram. A special case rhombus will be a square. And then we have something kind of by itself, this, which is a kite. Yep. Okay, are we good on this one? All right, wonderful. Okay, let's move on. So we're going to learn something about when we're talking about a polygon, how do we measure it? So for example, if we have a triangle, there is a two way of can measure triangle. One is add up all the side length. That's called parameter. And we also can calculate its area, the space it occupies, area. So parameter actually pretty straightforward. We just measure all the side length. Like say if we have a quadrilateral, we just measure the lengths or the side length, then that's our parameter. But area measurement, that's depends on what kind of triangle we are dealing with. So we're going to have different ways, formulas to measure. Now, the simplest shape will be a square. And the square is, the area of square is defined as its one side. I say this is the side and another side. So the area of a square is defined as S squared, means S times S. So give us two dimensions. One is going this way, one is going up this way. So that occupies two-dimensional space. Now, in order to measure something, we also need to have a unit. In a square, our unit is just unit one. So if this is a 1 and this is a 1, then the area is called the unit square. Now the area will be 1. Now, of course, it could be like 1 feet by 1 feet, or it could be 1 meter by 1 meter, or 1 centimeter by 1 centimeter, or 1 inch by 1 inch. Doesn't matter what it is. That's called unit square. So you can see that when we measure something, we use that the unit square as our unit. Like we talk about square feet, square inch, all is about that. Now, so we got this. We know this is a unit square. Now, what happens if we got a square, which actually made, this is 1 unit, this is 2 by 2. So this is 1 unit, this is another unit. And we notice that if we cut like this, then we actually have 4 unit squares, which is 1 by 1. So since we got 4 unit squares, the area for that is just 4. But we notice that what we did here is we got if we got something like this, we got 1, 2 this way and 1, 2 that way. So that actually is 2 times 2. So that's where, which is what we have for 4. When you have something like, say, 3 by 3, then we got 1, 1, 1, 1, 1, 1. How many unit square we got? 3 times 3 is 9. So 3 times 3 is 9. So therefore our formula, when we have a square, doesn't matter what square it is. Our formula is always the side square. And depends on the unit. We could be, if this is the unit is in inch, then we say it's inch squared, or the unit is meter, or the meter squared. Okay, are we good on here? All right. So I let you do a couple of exercise. Now, if you have a square that is 5 by 5, and what is the area? You can type on the chat. Very good. Okay. All right. Good job. So now we have that square pretty easy. Now we got into rectangle. So how do we do rectangle? Well, same thing. Basically, to measure something, we just want to see how many unit square it has. So when we say this is 3 and 4, let's say 3 inch and by 4 inch. Now, how many 1 inch, 1 square inch unit square we can have? Well, you can see we can cut down like that. Then we got that. So therefore, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 3 times 4, give 12 unit squares. So that would be inch square. Really doesn't matter, depends on what we have here. And this is why we have the formula that is, we call this length times width, and length times width. Sometimes we call this as the base, and this as our height. So the base times height. No matter what, is always one side times other, because that's how many units square we can get. Okay, are we good on this one? Thank you, Mason. Thank you, Mia. Thank you, Roger. Okay, now if we do something like this kind of square, we got 4 here, we got 6 here. What is the area? Good job. Very good. So now we know how to do area. We know the rectangle. We know that is right as length times width, or base times height. And so basically this tells us how many unit square we have to occupy this shape. And one thing you actually, if you want to make a floor, you have to buy something to make the floor up. That's where you have using the area formula to count, like how many little square, unit square shapes you need. Okay, we have that. Then we got into parallelogram. Parallelogram is going this way. And we know this side and that side are parallel. And so how do we find the area of that? Like, for example, this is 5. So if this is a 5, by definition, parallelogram on the top will also be 5. And said if this is the height is 4, height is always the distance between the two lines here. And which that it will make a perpendicular kind of line here. Yeah, so we're not by this line. We're looking for this line, which is the shorter the distance between two lines. Okay, so in that case, we actually can do some trick. We can cut this down like this, and then we put this over to other side. You can see that will make a perfect rectangle. So therefore, now for the rectangle, the area is base times height, which in this case is 5, and this case is 4, so it's 20. And you can see that we can change a parallelogram into rectangle. So therefore, the area formula for parallelogram and rectangle is the same formula. Okay, are we good on this? All right, thank you. So now let's see, we got parallelogram here. And this base is 7, and the height here is 5. What is the area of this parallelogram? Good job, Mason. Job, Roderick. Job, Mia. Reason, you good? I think yeah, he's frozen. Some connection issues. Okay, now we know how to do a square, which is this. Then we know how to do rectangle, and then we know how to do parallelogram. So now we actually going to do trapezoid. Trapezoid have two sides, and this side, and then we have something like that. Yeah. Let's say this is 3, and this is 7, and our height here is, let's see, 5. So how do we do that? Because we know the height, and we know two bases. One is 3, one is 7. Now you have two bases. Now which base we're going to use? Well, we actually going to do a trick here is we're going to copy this trapezoid and flip upside down and put them together. And you can see that we actually got in this. And this side is 7, this side is 3. So kind of upside down and put together. And you can see that this is a perfect trapezoid. Now the area, sort of not trapezoid, parallelogram. And the area for the parallelogram we know is pretty simple. We know the base here is 7 plus 3. And the height is 5. So that's area of the whole parallelogram here. But the area for the trapezoid is half of that. So it equals, our formula is half of that. So that gave us half. 10 times 5, then give us 5 times 5, 25. So that's why we had this formula, half base 1, this one, plus base 2, then times height. So we have this this formula. So are we good here? Thank you, Mason. Thank you, Roger. Thank you, Mia. Okay, now I'm going to give you a trapezoid, and you work out the area. So we got trapezoid. Trapezoid, let's see, we got this, and this is, say, 4, and this is 6. Our height here is 7, and see what you got. Good job, Raji. Good job, Mason. Hello, Mia. Hello, Mia. Hmm. Hello, Grayson.
Hi, sorry, I'm having computer troubles.
Yeah, okay, no problem. Yeah, we are getting on the working on the trapdoid, and it is the trapdoid is actually half of parallelogram. So if you push that upside down, we got this. So it's 4 and 6. So therefore, this rectangle, no, parallelogram is 6 plus 4 times height, in this case 7, but the trapezoid is half of that. So then we got half 6 plus 4 times 7. 6 plus 4 is 10. 10 divided by 2 is 5. 5 times 7 is 35. So that's how we got that one. Okay, let's try another. Okay. Good job, Raji. Good job, Mason. Good job, Mia. Good job. Okay. Let's see. I'm going to get something kind of weird. Okay. So as long as those two lines are parallel, it's a trapdoid. Okay. Good job, Mason. Yeah, don't forget to divide by 2 because a trapezoid is half a parallelogram. Good job, Mia. Good job, Raji. Okay, so remember for the trapdoor, our formula is half base times height. So in this case, it's half our, sorry, not half base times, that's for the parallelogram. Yes, good job, Grayson. Half base 1 plus base 2. Another way you can looking at is half base 1, base 2, basically is the average base of the two bases, then times height. So this one 6 plus 3 times 4 is half, 9 times 4, then 4 and 2 can cancel, we got 2, so we got 18. Okay, very good. So let's kind of do a recap here. We know this square formula is s squared, if we got one side and that side. And we got rectangle. We use that to mean they are 90 degrees. We got base, then this side is the height. So the area is base times height. Then we get parallelogram. And we got base and height. So the height is perpendicular to the base, and area is base times height, same area. Those two have the same formula. And then we got parallel trapezoid, and we got base 1, base 2, and we got here, which is our height. So the area is half base 1 plus base 2 times height. Okay, all good here? All right. Yeah. So, and as far as the quadrilateral goes, we haven't dealing with the rhombus and the kite yet. But to do that, we actually have to know what is area of triangles, because this actually made the two triangles, this triangle and this triangle, and actually two isosceles triangle. And for the rhombus, is the same. If you cut this in the middle, we made of two isosceles triangles. So that's something, if we know how to do triangles, we can do those two. So now we got into triangle. Now, if you have a triangle like this, and we know a base, and we know the height is always perpendicular to the base. Now, how do we find the area? Now we're going to do the same trick as we did for trapdoor. We're going to copy this triangle and we put that upside down, and then we put them together and we'll get this. This is our B. So what we got here is a parallelogram. Now on the parallelogram, the area is base times height, but our triangle is half of that. So we actually have half base times height. And that's where the half come from when we do the formula. So that is half base times height. So if I have a triangle, say like this, we got 10, but our base here is say 7, then our area will be half base times height. And that'd be 5 times 7 and equals 35. Yep. Are we good here? Thank you, Mason. Thank you, Raji. Thank you, Grayson. Thank you, Mia. Okay, now let's do a couple work here. One is this. This is, say, 9. Our height here is 6. What is our area? Good job. Good job, Mason. Good job, Raji. Yeah, don't forget the half because the triangle is half of a parallelogram. Hello, Mia. Do you need more time? Okay. Well, remember how we do a triangle. Triangle is half of a parallelogram. And we know how to do parallelogram. Parallelogram, the formula is base times height. So therefore, the area will be half base times height. Our base is 9, our height is 6. Remember, the height is always perpendicular to the base. It has to be like that. Otherwise, you get wrong. Okay, because we cannot use this length. We cannot use that length. We have to draw a line here to perpendicular to the base and use that. So now in this case, now we know 3 divided by 2 is 6. 6 divided by 2 is 3. 3 times 9 is 27. Okay, all good. Are we good here? Thank you, Mason. Thank you, Raji. Thank you, Mia. Thank you, Grayson. Okay, let's see. We have another triangle. And this one is 10. And down here is let's say is 9. So what's the area? Good job, Bharati. Good job, Mason. Good job, Mia. Good job, Grayson. Okay, let's do one more. We got a triangle here. And we got 5. And this one is 6. Good job, Roger. Good job, Mia. Good job, Mason. Good job, Chris. Very good, very good. So that's basically we have for now we know how to do the triangles. So therefore we can go back to do to do, this is a rhombus. And we know that all the sides are the same, but the angle are not a right angle. So basically we're making this, that. So if we know this is 4 on each side, and we know this is say 10, how do we figure out the area? This is the two right triangles, and we know that the triangle is half base times height, but we don't know the height. Well, if we know this one, if this diagonal is say 6, then we know this part will be 3, and this part, the whole part here will be 10. So the area will be half 10 times 3, right? The whole thing here is 6. And to make this triangle, that's 3. And the base is 10, but that's just half the triangle. There's a half. So we have times 2 here. So all we got here is 2 and 2, we got 30. So therefore, if we know rhombus, and we know there, we call diagonal. The diagonal is here and there. And if we know the diagonal, let's see, this is our, the diagonal here is, let's call them D1, and let's call this and D2. So our area formula will be half D1 times half D2. So why is that? Just like we showed, I showed you here early on, this is, we got 2 triangles. This triangle, the base here is D1, and the height here is half of D2. So it's half of D2. And the area for this one is half of that. And then we need to add this part with times 2, then we got half D1 over D2. So that's got our area for rhombus. And give some examples. If you got rhombus like this, and this side is 10, and this side is 6, then the area will be half 10 times 6. That give us 30. If we got the rhombus like this, and this is say 12, and from here to here is 8, then our area will be half 12 times 8. And we cancel that, we got 4 times 12, 48. Okay, are we good on this? Wonderful, good. So basically we're going to use the area for triangle to find the rhombus. So lastly is the kite. Kite actually 2 that here. And for that, we need to know this diagonal, and we also need to know this side. And you can hear this side and that side, we made actually 2 triangles here. But the top triangle is not congruent to the bottom triangle. So that is going to be a little bit trickier. So we have to know for this one, we need to figure out what's this length and what's this length and what is this length. So basically we made the 2 triangles. We just based on triangle formula, half base times height. But that is depends on what kind of height we have. Like say, for example, the height here is 8 from here to here. Now this part is 3, and this part is say 6. Then we've got 2 triangles, half the base 8 times 3 plus half, still the base 8 times 6. So then we got this case we got half that 4 times 3 is 12, and this give us 3 times 8 is 24. Then we got 36. So that is kind of just show an example. The for polygons can always turn that into triangle. For example, the pentagon is like this. We actually can cut them into one triangle and a trapezoid. So then we can measure as a triangle and a trapezoid. Now, if we have a hexagon, well, actually hexagon like this, we got 4 sides, and you can see that you can cut them. That made of 2 trapezoid. And if you have a octagon, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5. Let me redraw that. Redraw octagon. So actually it's here, 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 here. 1, 2, 3. Oh, forgot there's another one here. So 1, 2, 3, 1, 2, 3, 8. Now you can see that if we cut them, we actually got one trapezoid, another trapezoid, and we got a rectangle. So we just use that formula to do that. So, and you can see that as long as we know how to do triangle, actually it all comes down to is as long as we know how to do parallelogram, say B and H, then we know triangle basically half a parallelogram, so it's half base times height. This is base times height. Now a rectangle is special kind of a parallelogram, so it's base times height. And we got trapezoid. We got base 1, base 2, and we got height. Then the area is half base 1 plus base 2 times height. And this can make into a parallelogram, right? We said that if we copy this, turn upside down, we make a parallelogram. And similarly for triangle, copy this, put that upside down, we get another parallelogram. So as long as we know the parallelogram is area is base times height, we can derive all kinds of formulas for trapezoid, for rectangle, and for triangles. So as long as we know how to do triangles, we pretty much can do the area for all kinds of shapes. Okay, are we good here? All right. I'll see you guys next week. Okay, don't forget to finish your homework. Okay, bye.